Welcome, students. I am Aurora, the artificial intelligence system on Spacegate Station. In this episode, you will be reviewing the primary difference between intrinsic and extrinsic properties of matter. Stand by for transfer.
Mission Control, this is Spacegate Station. Please advise Chief Meteorologist Tim Deegan of First Coast News in Jacksonville, Florida, USA, that meteorologist Robert Speda has safely arrived at the station. He's presently taking a break from his meteorology work to help Professor Kiechler on samples retrieved from the OSIRIS Mark 9 spacecraft. Will do, Mission Control. Spacegate Station out.
Specialist Barber, this makes the fourth call from Mission Control in the last hour regarding the OSIRIS Mark 9 spacecraft mission.
Yes, Aurora. The safe retrieval of the OSIRIS Mark 9 spacecraft returning from Jupiter's moon Io is of utmost importance to NASA scientists.
Processing. The OSIRIS project was initially started in 2016 with the launch of the first OSIRIS spacecraft. Its primary mission was to land on an asteroid and return with a science capsule containing material from the asteroid for study.
That's correct, Aurora. That first spacecraft retrieved several hundred grams of asteroid material that was used by scientists to learn about the early stages of the solar system.
Specialist Barber, I am confused why Mr. Speda from First Coast News is assisting Professor Kiechler on this project.
Well, Aurora, Robert Speda is a meteorologist.
Processing. A meteorologist studies the science of atmospheric properties and phenomena, which includes the atmosphere's physics and chemistry.
Well, not only that, Aurora, but Mr. Speda also has a background in atmospheric systems technology that he got from his time serving in the Navy. Therefore, his unique background is very useful to scientists who are studying extraterrestrial objects like planets and moons.
I agree that his participation would be very useful on a project like this.
Well, great minds think alike.
Processing. Specialist Barber, I am confused. It would be impossible for NASA scientists to have the same computing power as an artificial intelligence system such as myself. Therefore, how can you equate their mental faculties with mine?
No, Aurora, I was using another idiom. In this case, the expression just means that you found someone who thinks the same way that you do. You know, I have half a mind to tell them you said that.
Specialist Barber, I was not aware that you had suffered cerebral damage resulting in the loss of half of your mental capabilities.
No, Aurora, that is not what I meant.
This would explain a lot regarding our dealings with each other.
Excuse me?
Would it be helpful if I communicated with you more slowly and clearly and gave you plenty of time to respond so you can think about what to say? I can also be more patient and offer reassurance during our conversations. I will give you time to consider a response.
Aurora, that is not what I meant. I have got to stop getting myself into these situations with her.
Aurora, open a new research file. Subject, OSIRIS Mark 9 probe, soil evaluation.
Yes, Professor Kiechler. File now open, and I am recording.
Mr. Speda, I really appreciate your help with the soil evaluation. It's always good when we have another scientist helping with lab investigations.
Well, it's my pleasure. I actually came here to look at some long-range weather data on the space station, but I'll help with anything on board, especially if it's for scientific and research purposes.
So today we're going to be evaluating the soil taken by the OSIRIS Mark 9 probe, and we'll be able to see what the samples showed us from the moon Io.
Io is the innermost of Jupiter's four largest moons. It has a very thin atmosphere primarily made up of sulfur dioxide. The surface temperature is negative 130 degrees Celsius or 202 degrees Fahrenheit, resulting in the formation of sulfur dioxide snowfields. Io is home to roughly 400 active volcanoes. the lava from which can exceed 1,000 degrees Celsius or 1,832 degrees Fahrenheit.
That is correct, Aurora.
Well, Professor Keesler, where would you like to start with analyzing these soil samples?
Well, first we want to analyze them based on their properties.
All right, so which properties do you want to evaluate first? Or physical or chemical properties?
Processing. Physical and chemical properties are both used to describe matter. Chemical properties are those that can only be measured by attempting to change the chemical identity of a material through a chemical reaction. Physical properties are those that can be measured without having to change a material's chemical identity. Physical properties are dependent upon the chemical structures and features of substances, such as how their molecules and/or atoms are arranged in space and how much energy is available to them.
That was well stated, Aurora. You see, Mr. Spetta, since chemical properties involve testing the material's flammability, pH, and reactivity with water, that's going to be a much more involved process. We'll have to do that later.
All right. Well, that just leaves us with the physical properties, which means we're going to have to look at the intrinsic and extrinsic physical properties of these soil samples taken from Io.
Exactly, but first we need to define what extrinsic and intrinsic properties are.
Intrinsic properties, also known as intensive properties, are properties that are within a given substance. These properties do not depend on the amount of material that you have. The best way to remember this is to focus on the prefix in to remember that it is within the substance. Extrinsic properties, also known as extensive properties, are properties that depend on the amount of the substance you have. All size measurements depend on amount, so all size measurements are extrinsic properties.
Thank you, Aurora. So, Professor Keesler, which properties do you want to look at first?
Well, I suggest we look at the most common properties. Aurora, start a subfile for classifying the intrinsic properties of the soil sample from the moon Io.
Processing. Creating an intrinsic property file for sample 1, which will include the most common intrinsic properties, which are melting point, boiling point, hardness, malleability, and density.
Very good. Now, Aurora, please define in the file each of the intrinsic properties you have listed.
Yes, Professor Keesler. The melting point of a substance is the temperature at which it changes state from a solid to a liquid. At the melting point, the solid and liquid phase exist simultaneously as it transitions from one state to another. The boiling point is the temperature at which a liquid transitions to vapor or gaseous phase of matter. At the boiling point, the liquid and gas phase exist simultaneously as it transitions from one state to another. Malleability allows a material to be spread into sheets or films. Hardness is a measure of its ability to withstand being scratched, cut, or dented. Density is how much space an object or substance takes up, or how closely packed the molecules of the substance are.
That was well done, Aurora.
You know, Professor Keesler, I think you might want to consider adding odor and color, as they are also intrinsic properties.
I agree. Aurora, please add color and odor to the list.
Processing. Color represents the quality of an object or substance with respect to light reflected by the object. This is usually determined visually by the dominant wavelength of the visual spectrum seen and permits colors to be classified as red, yellow, green, blue, or an intermediate color. Odor represents the classification of a substance by the human olfactory organ. There are 6 basic classifications, which are musky, which would be perfume-like, putrid, which would be the odor of rotten eggs, pungent, which relates to a vinegar-based smell, camphoraceous, which is like mothballs, floral such as roses, or pepperminty like gum.
Good. Now let's go ahead and use our sensor to evaluate our soil sample.
All right.
Boiling point, 2,950 degrees Celsius or 5,340 degrees Fahrenheit. Melting point, 1,713 degrees Celsius or 3,115 degrees Fahrenheit. Density, 2.68 grams per cubic centimeter. Hardness, hard, brittle, crystalline, and solid structure. Color, a blue-gray metallic type luster. And the odor, slightly pungent.
Well, that does give us half the data we need, but don't we also have to look at the extrinsic properties?
You're right. Aurora, please start a subfile for classifying extrinsic properties of our soil sample from the moon Io.
Processing. Extrinsic properties do depend on the size of a sample. For example, mass, volume, and heat content are all considered extrinsic properties. Mass represents the total amount of matter or stuff you have when evaluating a given amount of an object. This is not to be confused with weight, which involves the force of gravity on an object. Mass always stays the same, but weight can change depending on how gravity is acting upon an object, which, as whether you are standing on the Earth or the Earth, Moon. Volume, like mass, simply refers to the amount of space occupied by a three-dimensional object. Heat content relates to the amount of heat energy released by combustion of a quantity of a substance.
Well, those were very good descriptions of extrinsic properties, Aurora.
Let's go ahead and use our sensor again to evaluate the material.
All right.
The mass weight at Earth's normal is 2.54 grams. The volume, 0.95 cubic centimeters. The heat content,
Well, let me use this.
heat content 7.10 joules per kilogram.
All right, well, now that we have all of our information on the material, what's next?
Well, for this next part, we'll need Aurora. Aurora, please use the information regarding the intrinsic and extrinsic properties of the material we analyze and compare it to your database of known elements and compounds.
Processing. This material is primarily silicate oxide, which is the predominant component in silicate minerals. Silicate minerals are widely distributed throughout much of the solar system. Silicates make up about 95% of Earth crust and have been found in lunar samples, meteorites, and most asteroids. In addition, other planetary probes have detected their occurrence on the surfaces of Mercury, Venus, and Mars.
Well, then this confirms what most of us already believed in the scientific community about our samples from Io.
That's absolutely fascinating, and I enjoyed helping you evaluate this data from the Osiris Mark 9 mission, but I do have some work myself to do, gathering some weather data from the Spacegate weather station.
It was a pleasure working with you. Hopefully I can work with you on the weather research next time.
Well, you want to help me? I actually have some statistical analysis to go over.
Oh, okay. Aurora, please close out the file on this investigation for now. It looks like I have some number crunching to do.
Yeah, it should only take 5-6 hours maybe.
Awesome.
Terminating recording of laboratory investigation.
Well, Professor Keechler, how did the analysis of Io's material go?
It went very well, Specialist Barber. Mr. Spetta came in from First Coast News. He helped me with all the soil investigations. It went very well, but I hate to see that he had to go back to Earth so soon.
Well, I'm sure First Coast News has missed him. You know, I hear he's one of the best meteorologists there.
I'm sure he is. He came in to help me, and you know what they say about meteorologists, right?
I hate to ask.
He has a high-pressure job.
Now that was a pun.
Processing. A pun is a joke exploiting the different possible meanings of a word. Professor Keechler, I have been practicing my ability to deliver jokes. Would you like to hear some?
Sure, Aurora.
Don't say I didn't warn you.
Why can't doctors work with meteorologists?
I don't know. Why can't they work with meteorologists?
They're always under the weather.
Okay, now that was funny.
Where do meteorologists save their weather predictions?
Where do they take them?
In the cloud.
Okay, I don't think they're gonna get better.
Did you hear about the meteorologist competition?
No, I didn't hear about that, Aurora.
The losers got precipitation trophies.
Okay, well, on that note, I think we are done with our meteorology jokes for today. Please say goodnight, Aurora.
Good night, Aurora.
Never mind.
This concludes our latest episode of Spacegate Station. Please join us on our continuing adventures as the crew of Spacegate Station provides engaging enrichment or remediation-based instruction to improve your understanding of science, technology, engineering, and mathematics, terminating communication with Earth.